All right, looks like the mic is working. It's not muted out down there, so great. Here we go. We're doing the review number 1 for quiz number 1. Woo-woo! Here we go. All right, so segment addition postulate. This is the easiest one you're going to see in the test. I'm not going to give the one that's like, this segment's 3, that one's 4, what's the whole length? It's 7, right? I'm taking those off. But the good news is, if I take it off, it means it doesn't waste your time, and I spot you the points, right? Go, now. So the idea is still the same. If that's 3 and that's 4, the whole thing's 7, right? Well, if that's x plus 5, and this is 10, if we add them together, they should add up to what? 3x plus 3. Close. Yeah, there's an x there. Don't forget your x's. Stalk them on Instagram. All right, x plus 5. Adds up to, or adds with 10. And that will end up equaling the whole darn thing. And we know what the whole darn thing is. It's 3 plus 3, yeah? Okay, cool. So now we do some work. 5 and 10, that can go together, right? That makes 15. And then we have 3x plus 3 still over here. Again, terrible idea in real life, but a great idea in mathematics. What are we going to do? Get our x's together. Very good. So that x I'm going to move over. Now, whenever we move, verbs matter in here, okay? Whenever we move something in an equation, we do it with addition or subtraction. We do not do multiplication or division. You're thinking, wait a minute, sometimes we do. No, we don't. I'll show you why. We are moving the x over. So am I going to add it or subtract it to move it? Subtract it because it's already positive. So 15 equals 3x minus an x, 2 x's, only 2 x's left. That's our goal in life, is only to have 1 x, right? So now we're going to subtract 3 to move it over, right? Again, when we move, we either add or subtract. So I move it by subtraction. Now freeze. Before we had 1, 2, 3, 4 terms here. 4 ideas. Terms are anything that is separated by a plus or a minus. I'll zoom in for you. So we had 4 terms, thank you very much. 1, 2, 3, 4, because they're separated by a plus or a minus. See down here, is the 2 and the x separated by a plus or a minus? No. So it is one idea. So we don't move. We don't want to move the 2 and the x. We could if we wanted to, right? We could subtract it and move it all over. But we don't want to do that. We want to leave the x alone. We want to get the 2 separated from the x. Un momento. So what are we going to do to separate the 2 from the x? What's another word for separate? Divide. So we're not moving the 2. We're separating it from the x. Earlier we moved stuff by subtracting and adding, right? Now we're separating. That's division. So we divide. And when you separate, this is true in a divorce, everything gets divided. So we divide everything by 2. Yes, but we don't. We didn't. We were fools. That's algebra. So we divide everything by 2. Now luckily, there's only 2 things to divide. But imagine if we had divided by 2 earlier, because you have the choice. You can. But then you got to divide all this stuff, right? And we'd rather not do that because that can create a lot of fractions. Again, this going with the divorce theme here. All right, so 12 divided by 2 is 6. 2 divided by 2 is 1. So instead of 2 x's, we now have 1x, which is always the goal for algebra. We just want to have 1x, right? That's it. Don't want to have 0 x's. You want to live a little bit, right? But more than 1, a little too much, especially at your age. All right, questions, comments, concerns? No. Other than about me? Yes?
Okay, so like, okay, x plus 15 equals 3x plus 3. How do we get that to 50? Where did the 2x in the...
Freeze. Hey, I got this. So what you're telling me is that up to here, you're good.
Yeah.
Okay, but then here we lost you. Small thing that you're missing that's causing a huge issue. I subtracted x from both sides. So I got rid of the x, and I subtracted to get to 2. That's okay. She's sitting in the back, guys, going like this the entire time. She cannot see. And you know, when I zoomed in, it was like on this one, which is why she was good after that. Okay? So I got it. It's cool. All right. Next page. That's the easiest one you're going to see. Now let's go look at the hard one, okay? Let's look at 5. 6 is also difficult, but 5 we're going to do because it has a mouse there. See him? On the screen right now, it looks like I have a mouse going around because that's a computer screen, but it's not. It's analog. Isn't that cool? I have an analog mouse right now. I don't know. It did it at number 3 on the first side too. Don't look. We don't have time. All right. So it says find VU. Now, what we're going to do while we find VU is first we're going to find the whole darn thing. Okay? Because after that we'll know what x is, and then we can plug in x here to figure out what VU is. So here's the plan. Here's the plan. Okay. So if we know VU plus UT equals 14x, we should probably write that down. And we do know that because this bit plus this bit adds up to this bit. Do you see it? Do you see it, Mr. Krabs? I know. I never get to use that, though, so I had to adapt it. All right, so we have 6x plus ut. Ut is this little bit right here, right? And that's going to add, I know, right? And then that's going to equal this bit, the whole thing, 14x. We cool? Do you see where I got that from? Do you see the logic?
Yes.
Bit plus bit equals the whole thing, okay? So now we're going to do math. Now notice we've got two variables, an x and a ut. Yikes. So we are going to get an answer that has a bunch of junk in it. We're going to get ut equals a bunch of junk. It's not going to be ut equals 4. That's okay. Okay? Exactly. It's going to be multi-step. That's fine. So we're going to get ut on its own because that's what we want to know. We want to know how much the segment is. So how do I move the 6x? I want to move both the 6 and the x, not separate them.
Subtract.
I subtract. Boom. Everybody's like, teach them PEMDAS. No, how about we just teach them ideas? What's 14x minus 6x? 8x.
So UT is 8x.
That's what everybody needs. 8x. All right, so ut is 8x. All right, what about this one? These two add up to this one. Do you see it? Do you see it now? Beautiful. If you need to do this, do this. Get some pens, okay? Borrow some of mine for the quiz tomorrow. Preferably don't use these. Okay, I'll bring in these if I can remember. So this adds up to that. So we have 6x again plus wv. And that's going to equal 10, which is convenient. So once again, we're going to get wv on its own. We're going to get wv equals a bunch of junk. That's fine. How do I move the 6x? I can move the 6x. How do I do it? Subtract it. We always can move stuff.
Are you done? Yes.
Are you good now, Justice? For real, are you good?
Sure, we'll go with that.
Well, hold on. So I subtracted 6x from both sides.
This is supposed to be
WV. Okay. Did you think that we couldn't move it because we can't subtract it from 10? Is that what you're saying? He's right. I didn't understand what you meant at first, but he's right. We can't do 10 minus 6x. Right? That's as simple as it gets. You're right. I moved it over. That's cool. But it's not going to change like this one did. Are my words making sense right now? I'm explaining it very loosely, but I'm glad you understand. I'm always shocked when students understand what I'm saying. WV equals 10 minus 6x. Okay, we still don't know what VU is. But now we know that we can add this part, and this part together to equal the whole thing, which is 19x minus 1, right? So if we know that, write it. Maybe something good will happen, right? So 10 minus 6x plus the middle part. What's the middle part? 6x plus 8x is going to equal the whole thing. Let's do red. So this thing is red. 19x minus 1. Okay. Now we combine what we have. So negative 6x and 6x are on the same side, which is convenient because they'll cancel, right? If we subtract 6 and add 6, how about we just save time and don't do either, right? It's a waste of time. So I cross them out. Negative 6 plus 6 is 0. 10 plus 8x is what we're left with on this side, and 19x minus 1 on the other. Terrible idea in real life, great idea in math. What are we going to do? Yep, we're going to put our x's together. So subtract 8x to one side. So we get 10 over here equals, what's 19x minus 8x? 11 x's. A lot of x's. Anybody top that? Yeah, boy. All right, so here we are. 10 equals 11x minus 1. We can divide the 11 now. Again, you're free to do whatever you want. But let's save that for last because then we're going to get fractions, and I'd rather not. So let's just move the 1. How do we move the negative 1? We add it. Very good. So we get 11 equals 11x. And we waited, and look, it paid off. No fractions. Because when I divide by 11 to both sides, and again, when you divide, like in a divorce, you divide up everything. Luckily, there's only 2 things, right? We did a prenup, perhaps. So we divide it up, and we get 11 divided by 11, which is 1. And that's going to equal 11 divided by 11x. Let me say it again. 11x divided by 11, which is regular x. So we're down to 1x, and x equals 1. Are you having an aneurysm because we did all that work, and we got 1 as an answer, which is kind of depressing?
Yes. Which means.
Gotcha. So what is VU? VU is 6x. If x is 1, 6. And it's not true that you don't do math. You just answered most of my questions right now. It's on tape. We have it. There's proof. You did math. You do it.
I copied what you had.
But you were answering questions out loud with your mouth. I know you don't realize, like, you talk and things come out all the time, but you do, and sometimes they're good things. So, x is 1.
Sometimes is the key word.
Questions on that one? That's the hardest one I can give you.
Oh.
What?
So the answer is actually 6 rather than 1?
It is, because they want to know VU, right? So technically this is the answer, but every other class today, I didn't realize that was what they were asking because I forgot the directions by the time I got done with the problem. And I'll accept either for now. Have you ever been there, right? You get x equals and you're like, I'm done, this is algebra, that's how algebra works. No, you got to plug it back in, you goof, right? Turn the page. All right, check it out. Number 7. Number 7. Scott would know that if you, well, you're not going to see Scott anymore, never mind. I was going to say Scott would know. Number 7, he would know what that means. It's an inside joke from a long time ago that just popped into my head. Scott, if you're watching, hello. 7, A, B, and C are collinear. What does it mean, speaking of words that have meaning? What does collinear mean?
They're all on the same line.
Same line. Thomas is raising hand. I appreciate that, but you know what? Sometimes you just got to be quick on the draw. So, co means same, linear means line, right? So let's draw that. You guys are all in favor of doing this in your head. How about no? This is geometry. You got to show proof. Teach someone what you see in your head. That's real understanding. So A, B, and C are collinear. A, B, C. Easy as 1, 2, 3. A, B is what we're looking for. B, C is 6. And the whole dumb thing is 17. That's AC, right? So children, if the whole thing's 17 and part of it's 6, the other bit is what? 11, right? Because 17 minus 6 is going to be AB, which means AB is 11. If you want to be fancy, therefore, 11 equals AB, right? Bam, smack. So, 8, it has letters in it, but you're going to be fine. It's the same dumb thing. It's the same thing. The two little bits add up to the big bit. Let's look at 9. 9 on your homework. It's just I combined two things. Remember your homework had like that big thing where you had to plot all the dots? And then later on it was like, use the distance formula, right? I'm doing it all at once here to save on space. It's going to be fine. Lots of directions. Just read them. You'll be okay. I will probably do that to save space in the quiz. I hand you a quiz, and they don't count the questions. They go, oh, this is thick. And I go, yeah, with 3 C's, right? But there's really only like 10 questions, but they whine about it because you guys aren't smart, okay? I just give you lots of space to show your work. You're welcome. Right? Don't you hate it when the math quizzes are all jammed together? It's the worst. So this is thick. The quiz will be less thick. Sorry, like 1C, right? And it will have even fewer questions. How many questions are in this packet, by the way? Too many. All right, you go to page 7, and we have 14 questions. So it's 2 questions per page. Thank the Lord, right? So here we go. And remember, these are not due for a grade. So I didn't break my homework rule of 10 to 15 questions max, right? Because this isn't for a grade, and I'm doing like half of them with you. I'm just giving you lots of examples, right? Examples are good. Everybody loves examples. All right, plot the given points. 4, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's in quadrant 1. 8, 1. There's 4, so 5, 6, 7, 8, up 1. I'm going to label those so everybody knows what they are, and so I don't get goofed later. You should do that too. Now it says state which quadrant each point is in. Well, both are in the same quadrant. And what quadrant is that? Uno, capital I. And then use the distance formula to find the distance between them. So now let's draw a line between them. Improvising with a straight edge, that's not going to even work, right? Yeah, nice. Okay, so we're going to find the distance. Let's call that distance C because distance starts with C. Really, it's because Pythagorean theorem, right? Okay. Distance formula is this. Watch how I walk myself through this. I'm not going to write down the root of the quantity x2 minus x1 closed quantity squared plus quantity of y2 minus y1 closed quantity squared equals c squared. I'm not going to do that, okay? That's annoying and it's awful, right? Here's what I'm going to do. Distance formula is the same thing as what? Pythagorean theorem. I know Pythagorean theorem. It's something squared, a squared, right? Plus something squared, b squared, equals c squared. Right? I'm just leaving gaps because I want to use distance formula. Now, I didn't write c squared because at the end of the day, I want regular c. So what do I have to do to both sides? Square root both sides. So I'm setting it up like this. Oops, sorry, 2. You're inside. Don't forget the 2's. Everyone does. Don't forget them. I will take off points. You've been warned. So instead of a and b, what am I going to write? What do we substitute for a? No.
X.
Well, I always have a be horizontal. So it's the x's, right? So we do x2, x1. Is it plus or minus? Minus. Why minus? Minus. Subtraction is distance. And we want to know the distance between the x values. Check it out. What does that mean? Well, the x values are here and here. 8 and 4, right? We're asking how far are those two dots apart horizontally? Well, they're apart 4. 8 and 4. Okay? So the x values go here. Are we cool with that?
It's pretty cool in here.
I'm sorry.
Does it affect your answer if you switch them?
X and the y's, or the like if I did x1 first?
No, like if you put the...
It doesn't, no. Mm-mm. Good question, good question. That's the beauty. Remember, rotating the triangle, it's going to be the same triangle. All right, so now we got to do the vertical distance, right? Which we'll find out later is the distance between 4 and 1, right? But right now, vertical distance is y2 minus y1. I used to have a flip phone when people would call me in class. I'd just throw it on the ground and it would shatter in front of people and they'd be like, oh my God, right? But flip phones do that and they're fine. I almost did that with my iPhone. That would not have been good. All right, so here we are. That's the distance formula. It's Pythag, but with substituting the a and the b's for the x and the y's. Okay? You're going to forget, is it addition in the middle or not? Of course it's addition in the middle, because it's a squared plus b squared, right? Of course it's minus in the insides, because it's talking about the distance. So now we plug in the numbers. First, let's label our coordinates. So I'm going to call this x1, y1, and this x2, y2. You could goof it and switch the other way if you want. That's fine. I don't care. Just be consistent. And so when I plug these in, I hope I never start talking like that. If I do, I need to be put to sleep. All right. X2
Is
8 in my diagram, right?
Yep.
Okay, so I plug in 8. What's my x1 in my diagram? 4. Guys, check it out. 8 minus 4 is the distance. Look at this. 8 minus 4. That's where it comes from. 8 minus 4. That's how the distance is between these guys. This guy right here is 4. And then we've got y2, which is what? 1, and y1, which is 4. Don't goof up the order, okay? So now we do 8 minus 4, which is 4, like I said it would be, right, down here. And this is going to be 3, we can tell in our graph. Plus, what's 1 minus 4?
3.
Negative 3. And we keep the parentheses. Notice this. This is important. Here's why, children. Okay? Here's why. If we don't keep the parentheses and you type it into your calculator and your calculator does math right, you'll ignore it and you'll just do whatever you want. But the calculator is true. So if I write this, guys, what is the answer? 9. You'd think so, right? Because negative 3 times negative 3 is 9, because a negative times a negative makes a positive. It ain't. Here's why. Remember PEMDAS? It's a total lie. It only works 9/10 of the time, and the 1/10 that doesn't really screws you over, which is why I don't really teach it, and I teach people to think for themselves. But let's pretend PEMDAS is true, okay? In this case. And it is. Parentheses first, right? Then exponents. Then multiplication, right?
so exponents.
So check it out. This negative right here is saying take 3 and multiply it by negative 1. What comes first, exponents or multiplication? Yikes. So what it really says is take 3 and square it. What's that? 9. Now multiply it by negative 1. Oh, yikes. So if you want to do negative 3, the number squared, you have to do it like this. Parentheses says do me first. Okay, so make 3 negative. Done. Did it. We did it. 3 is negative. Now square it. Now it's 9. You ever wonder why your calculator does that? Now you know. Because it's stupid. No, because it actually knows what's going on. And you didn't know the difference between those. Okay. The negative is really a multiplication symbol. So here we are. With parentheses, what's negative 3 quantity squared? 9, because you make the 3 negative first. That's what's in the parentheses. And then you square it. So negative 3 squared is 9. If you didn't have the parentheses, your calculator would tell you that it was negative 9. And it would be right, based on your work. What's 4 squared? A fun game to play outside. So 16 plus 9 is? 25. The only thing funnier than 24, which means C is going to be equal to the root of 25, which is 5. Cinco. Shocker. Okay, so now we check our work with Pythag. That was the last bit. That's what these directions say. Okay, right there. I'll zoom out. There you go. So check it out. 4, how many squares are here? 3 is how many squares are there? Shocker. That's what we got here. After this point on down, it's Pythag. What is this? It's figuring out what the distance is between those two. What's the distance between 8 and 4? 4. It just did it algebraically. Remember when I told you it took 1,600 years for Descartes to come up with a coordinate plane and to connect algebra and geometry, and you're like, really? Why would it take that long? This is why. You didn't see it either. Algebraically, what's going on here is this. This visual. 8 minus 4 is 4. That's the distance. Here, between here and here, vertically between those 2 points, 4 and 1. The distance is -3. Distance can't be negative, so we square it. Then we root it to take it back where it was. Squaring gets rid of negatives. And then we root it, and now it's positive, and distance has to be positive. So squaring it and then rooting makes distance. So here we are with 5. I can prove this with Pythagorean theorem. I'm going to check my answer. It should be 4 squared, right? What's my other leg? What's my other leg? 3 squared. Yeah, because on this diagram it's positive. Distance is always positive. Equals c squared, right? What's 4 squared? Fun game to play outside. What's 3 squared? 9! What is c squared? It's c squared. Let's write it like this. 25 rooted, that's 5. That checks out. I need both. I need to see this, that you can do it algebraically. I need this so you can show me geometrically. You can do Pythag, okay? I need both. ¿Por qué no los dos? ¿Por qué?
That's please.
Nope, that's por favor. ¿Por qué means 2 things. It can either mean because or why, which is fun because you can say ¿por qué? Asking why, and someone can respond ¿por qué? Because. And go back and forth, right? ¿Por qué no los dos means why not both? Because I said so. We're going to do both. That's this. Turn the page. Another example for you to try. Turn the page. Another example for you to try. Everybody loves samples. These are free samples. Everybody loves free samples. Another example for you to try. I only gave you half a page. Sorry. Explain the difference between inductive and deductive reasoning. Who actually did the homework? That wasn't really homework, but I assigned it anyway. Put all your hands down. You didn't do it. So let's talk about it now because it's going to be on the quiz. I don't normally do that, but I wanted to make a point. A point. Okay, that was kind of a stretch. I get it. All right, so let's talk about inductive versus deductive. So inductive reasoning. The definitions I give you are great, but they don't juxtapose. They don't contradict. I need to know the difference between them, the distance between them, perhaps. Yeah. All right, so inductive reasoning. I don't need words. I just need this diagram. The inductive reasoning goes from the specific to the general. And you can go to the general to save some time, right? Isn't that something, right? Yeah, that's right. You need an example. So example, please. Remember from the notes, student 1, student 2, student 3, I interviewed them, and I asked them what they thought about math class. And they're like, we love math class. I'm like, of course you do, bunch of nerds, right? So specific students I interviewed, right? And they said they love math class. And I used that to imply, that's the arrow, that in general, all students must love math. Remember that symbol? All. So I took a specific case and implied the general case out of it. I interviewed 3 specific students, and because of that, those results, I can imply that everybody must love math. Now remember, it doesn't have to be true. Deductive. When I think deductive, I think deduct, which means to make smaller. So we start from the big. No, we start from the big, which is the general, right? The big is the general, and we deduct down to the specific. So here's my example. All, remember that symbol? Men are mortal. This is true. We know this to be true. That's a general statement about all men. Specifically then, that guy outside, who is a man, he gonna die, right? So Derek, that's me, is mortal. So thus, Derek is mortal, or it implies Derek is mortal. That's me, as far as you know. Horcruxes. Lots of them. Teachers are always like, I impart myself into my students. I do too, after I kill them and plant my soul into their bodies. That way I can be a lich and live forever. And that's a children's book. Have a good one. See you for the quiz tomorrow. Study, study, study.